Hello class, today we're going to talk about section 2.2, simplifying expressions. The first thing we're going to talk about is simplifying expressions by combining like terms. In order to do this, we need to know what like terms are. Like terms are terms with the same variable or variables raised to the same power. Some examples of like terms are 3x and 5x. They both have the same variable x, and since there's no power there, it's assumed to be 1. So their variables are x to the first power. Our second set of examples are 4xyz and negative 7xyz. They all have x to the first, y to the first, and z to the first. Therefore, since they have the same three variables raised to the same power, they are like terms. The last pair of like terms are 4a to the second power and negative 1 45/100 a to the second power. They both have a raised to the second power, therefore they are like terms. When you see that little funny symbol pointing up, it's called a caret, and that means raised to. And then you take the number after it, say that power. So if we had something like b caret 3, that would mean b raised to the third power. Please take a moment to pause this video and write down the definition of like terms and the examples of like terms. To simplify by combining like terms, we simply add the coefficients of the like terms and keep the variables the same. Remember, coefficients are the numbers directly in front of the variable. Let's try an example of simplifying by combining like terms together. When I do this, what I like to do is either underline all of my like terms or circle them, depending on how many like terms I want. I might have to square around some terms. It's easier to distinguish what the like terms are and add the coefficients together if you separate them that way. So I see I have a 3x. I'm going to circle that. I see another term with an x in it. I'm going to circle that. Notice I circled the symbol going with the term. Remember, terms are separated by addition. So if I circle all of the symbols going with my term, that will tell me whether my term is positive or negative. My terms in this case are 3x, 4, negative 5x, and 8. Now since I have no more x's, I'm going to go ahead and underline my other like terms. In this case, they are the constants, positive 4 and positive 8. Now I'm going to go ahead and add the coefficients of my like terms. 3 plus negative 5 is negative 2. Therefore, 3x plus negative 5x is negative 2x. Now I'm going to combine my 4 and 8 and I get 12. Therefore, the expression 3x plus 4 minus 5x plus 8 simplifies to negative 2x plus 12. Please take a moment to pause this video, write down the process for simplifying by combining like terms and the first example, and try the second example on your own. If you notice in the second example, I put a circle around all of my terms with just a y in it. I underlined all of the terms with xy, and I put a square around all of the terms with x's. When I combined my like terms, the expression simplified to negative 7y minus 4xy plus 3x. Next, we're going to talk about expanding expressions. What this means is we're going to use the distributive property before we combine our like terms. In case you're unfamiliar with the distributive property, we use the distributive property when we have a number outside of a set of parentheses with an expression inside it. What we need to do is distribute the number outside the parentheses to each term inside of the parentheses. So I'm going to distribute the 3/4 to the 12x and the negative 8. When I distribute the number, what I want to do is multiply it. So 3/4 of 12 is 9, therefore 3/4 of 12x is 9x. Now I distribute the 3/4 to the negative 8. 3/4 of 8 is 6. Therefore, 3/4 of negative 8 is negative 6. And the 3 still tags along, so I want to add the plus 3. Now my only step to finish expanding this expression is to simplify by combining like terms. My like terms are negative 6 and 3. Therefore, this expression simplifies to 9x minus 3. Please take a moment to pause this video and write the example down in your notes and try the next two problems on your own. If you notice in the two problems below, I started by distributing the term outside of the parentheses to each term inside of the parentheses. In the first example, I distributed the 6 and got 12x plus 18. The 4 still tags along, so I put the minus 4, and then I simplified the expression by combining the like terms, so the expression simplified to 12x plus 14. In the second example, notice when I distributed the number outside of the parentheses, I distributed a negative 3, not just a 3. Since it's 2 minus 3 times the quantity of 2s minus 1, I need to distribute the negative with it. So negative 3 times 2s gave me negative 6s, and negative 3 times negative 1 gave me positive 3. Then I simplified by combining my like terms and got that the expression simplified to 5 minus 6s. The last thing we're going to talk about is how to factor expressions. To do this, the steps are 1. Find the GCF, the greatest common factor. 2. Divide the GCF out of each term and rewrite the expression using the distributive property. Please take a moment to pause this video and write down the steps for factoring expressions. Let's try factoring one problem together, and then I would like you to try the next two on your own. If we look, my terms are 25ab and negative 5a. The greatest common factor between 25 and 5 is 5, so I'm going to write the 5 down out front here. And then both terms also have an a, so I can factor out an a as well. Now I'm going to open up a set of parentheses. When I do this, I want to divide 5a out of each term. 25ab divided by 5a is 5b. Negative 5a divided by 5a is negative 1. Therefore, this expression factors into 5a times the quantity of 5b minus 1. Please take a moment to pause this video, record the first example in your notes, and try the second and third example on your own. Looking at the second example, my greatest common factor between 2x and 8 is 2. So I pull the 2 out front. Now I divide a 2x out of both of my terms. 2x divided by 2 is x, and 8 divided by 2 is 4. Therefore, the expression factors into 2 times the quantity of x plus 4. In my third problem, I can factor out a 3y from both terms. 9xy divided by 3y is 3x, and 3y divided by 3y is 1. Therefore, the expression factors into 3y times the quantity of 3x plus 1. To check to see if you factor an expression correctly, you can always distribute the greatest common factor back to every term, and you should end up with your original expression. If you do not, then it means you have made a mistake and you should go back and check your work. Before finishing your notes, please record the following 5 problems in your notes as well as your answers, and come to class prepared to discuss them.